If you're taking the SAT, knowing how to use the built-in Desmos calculator can save you a lot of time. In this video, I'm going to show you 3 different SAT-style problems where Desmos can help you get the answer much faster. Let's get started. Okay, let's say that we have a problem. Find the solutions to this system of equations. And they give us some linear equation, y equals 2x minus 6, and another one, but this is not linear, this is quadratic, y equals x squared minus 6x plus 1. So to find the solutions, you could do the math and work this out on paper and solve, uh, or we could use Desmos and quickly graph these. So going over to Desmos, we can type in the equations. And then the solutions are going to be the intersections. We are expecting there to be 2 solutions, 1 solution, or no solutions. Because a quadratic is a parabola that opens up, that is this U shape, and then the linear 2x minus 6 is this line here. We're looking for the intersections, and it looks like we have 2 intersections. We can simply click here and find a solution, 1 comma negative 4. That is one of the solutions. And then we can go find the other intersection, and we can click there, and we can find the other solution, 7, 8. That means if we were to plug one of our solutions in to both equations, we would get a true statement for this one and for this one. And the same goes for any other solution that we find. 7, 8, we can plug those into each equation, and we would get a true statement for both of them. Say we have this question. For what value of c does the equation below have exactly one real solution? So 4x squared minus 8x plus c equals 0. They're asking, when does this equation, this expression on the left, when does this equal 0? So this, again, is an excellent uh, problem where we can use Desmos. So we're going to take this and type this into Desmos. We're not going to do the equals 0, and I'll explain why when we get to Desmos. So in Desmos, let's go ahead and type the problem as I said, 4x squared minus 8x plus c. And the reason we're not typing equals 0 is because that would be our output, and that's just, it's not necessary. We might as well say equals y or equals f of x, but that's not necessary either. We are looking for, when does this quadratic touch our x-axis, because our x-axis is where our output y equals 0. So c is this constant. We are going to use this add slider feature. It defaults to 1, and you can see when c is 1, this is what the quadratic looks like. You can see that it has an x-intercept here and an x-intercept here. The values right here are not important right now. What we should recognize is, hey, this quadratic has 2 solutions. The problem asked us, let's look at the problem. What value of c, what does c have to be in order for this expression to have exactly one real solution? So we are looking for, when does the quadratic have one x-intercept? Because the x-intercept is when the output is 0. So we're looking for changing the value of c to have one x-intercept. So you can hit the play button. It's probably easier to just drag it. As you drag it left or right, you can see the graph changes. If your eyes are over here, you can see as I change c, it goes up, it goes down. We're looking for one x-intercept. So if we go slowly, we can see right there. Let's see what it is. We have 1, 0. So 1, 0 is not the answer to the question. The question asks, what does c have to be? We look over here when c is equal to 4. Let's look at another question. Say the question asks, the function f of x equals, and they give us this quadratic 0.75x squared minus 24x plus 8, has a minimum value of k. What is k? So this is a quadratic, so you might start picturing, oh, this is going to be a parabola. A is a positive. It doesn't matter that it's 0.75 or 7.7 or whatever. It's positive, so it opens up. We are going to take this equation and type this into Desmos. It says it has a minimum value. We're looking for where is the, how low does it go, is basically what it is, right? So let's type it in. Let's make more sense of it by seeing it in Desmos. So when we type it into Desmos, we have this. It looks like where it's missing some. Let's just go ahead and zoom out. Essentially what we're doing is we're finding the vertex. And you can find the vertex by manually finding it opposite of b over 2a, but Desmos makes this go a lot quicker. So there is our vertex, there is our lowest point. It says it has a minimum value of k, so we're looking at what is that. And when x is 16, we find our minimum value. This goes as far down as negative 184. That is our value of k, negative 184. So today we use 3 different Desmos strategies: finding intersections, using a slider to solve for a parameter, and using the graph to understand a function. The goal isn't to use Desmos for every SAT math problem. It's to recognize when Desmos can save you time and help you avoid unnecessary algebra. Thanks for watching. Good luck on your SAT.